Good day, viewers. Welcome back to Manual Statistics Arena. Today we'll be looking at hypothesis testing. Hypothesis is simply a conjecture about a population parameter which may or may not be true. By conjecture, I mean hypothesis is any statement we make about parameters that may or may not be true. And then hypothesis testing is the method through which we try to validate those statements we make. So if I say it is going to rain today, or it has the number of times it rained in this week is 3, I have made a statement. But whether or not this statement is true, we don't know. So the process I use to validate the statement, to know that the statement is true or false, then becomes the hypothesis testing. In hypothesis testing, we have two types of hypothesis. We have the null hypothesis and then the alternative hypothesis. Let's begin with the null hypothesis. The null hypothesis states that there is a difference between a parameter and a specific value. With that being said, the null hypothesis uses the equality operational signs. So we have the equal to here, we have the less than or equal to, and then the greater than or equal to. So the null hypothesis uses the equality operational symbols. And then we have the second type of hypothesis, which is the alternative hypothesis. The alternative hypothesis states that there is a difference between a parameter and a specific value, or there is a difference between two parameters. As such, the alternative hypothesis uses the inequality operational symbols. So we have the not equal to, the less than, and then the greater than. The null hypothesis is denoted by an H with a subscript 0 or the not. And then the alternative hypothesis is denoted by H with 1 as subscript or an H with A as a subscript. In hypothesis testing, the symbols, the operational signs are stated in the form of words. So if we take the less than operational sign, the less than can be lower, it can be reduced, it can be decreased. If you take the greater than operational sign, the greater than can be higher, it can be above, it can be increased, it can be heightened. For any hypothesis question or in hypothesis testing, the null hypothesis is always stated first, and then the alternative hypothesis is stated afterwards. And the alternative hypothesis is the opposite of the null hypothesis. So for any hypothesis, we will first write our alternative hypothesis, then a semicolon. Then we bring our parameter, which in this case is our mean or the mu. And we bring our value. But for now, let's use K. So we have our alternative hypothesis, which is our HA, semicolon, then our parameter. So the null hypothesis uses the equality signs or the equality operations. So you realize that we have an equal to here. So the null hypothesis states that the mean equals K. And then we are saying the alternative hypothesis is the opposite of the null hypothesis. So if the null hypothesis is saying the mean equals K, then the alternative hypothesis will state that the mean is not equal to K. That makes this statement the opposite of that statement. Let's take some examples in stating the null and alternative hypothesis. Example 1. A university publicizes that the proportion of its students who graduate in 4 years is 82. A university publicizes that the proportion of its students who graduate in 4 years is 82. So let's try to state the null and alternative hypothesis from this statement. So a university publicizes that the proportion of its students who graduate in 4 years is 82. So we have our null hypothesis H naught. The parameter in this case is a proportion. So we have our P is 82. So a university publicizes that the proportion of its students who graduate in 4 years, so the proportion of its students who graduate in 4 years is 82. And then we have our alternative hypothesis, which is the opposite of this statement. So if the proportion of its students who graduate in 4 years is 82, then the alternative will be that the proportion of its students who graduate in 4 years is not 82. So from here we can realize that the alternative hypothesis is the opposite of the null hypothesis. Let's take another example. A water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than 2.5 gallons per minute. A water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than 2.5 gallons per minute. So we have the statement says it's less than, the flow rate is less than 2.5 gallons per minute. So we have our alternative hypothesis, then we have our null hypothesis and then the alternative. So in this question, the operation that was mentioned over there was less than, and less than is an inequality operation or sign. So the water faucet, the flow rate is less than 2.5 gallons per minute. Then we'll have our null hypothesis, which becomes the opposite of this. So the flow rate, if this is less than, its opposite will be greater than or equal to 2.5. For any hypothesis question, the emphasis of the statement is known as a claim. For example, in the first question, we mentioned that the proportion of students who graduate in 4 years is. So the is was an operation of the null hypothesis. So the claim in the first example was this, the null hypothesis. That was what the sentence was about. Because the question says the proportion is 82. And then in the second question, we have the flow rate being less than 2.5 gallons per minute. So over here, the sentence was focused on the alternative. So the alternative was our claim in the second question, because of the fact that what was mentioned in the question is the less than, and the less than is only used for alternative hypothesis. Let's take the third example. A cereal company advertises that the mean weight of content of its 20-ounce size cereal boxes is more than 20 ounces. So a cereal company advertises that the mean weight of the content of its 20-ounce cereal is more than 20 ounces. So it's more than 20 ounces. That's the critical part of the sentence or the statement. So once again, we have our null hypothesis and then alternative hypothesis. So that the content of the 20-ounce cereal box is more than 20 ounces. So you realize with this particular one too, the claim is the alternative hypothesis. So if this is what the sentence is saying, it's more than 20 ounces, then the null hypothesis becomes the opposite of the alternative hypothesis. So if this is more than 20, then the null hypothesis will be less than or equal to 20. So with regards to hypothesis testing, this is how we state the null and alternative hypothesis for any hypothetical question. So you always state, you try to identify the claim in the question, and then you state the claim, then you state its opposite. But in writing it, the null hypothesis comes first, and then the alternative hypothesis follows. Let's quickly look at types of errors. There are two types of errors in hypothesis testing. The first one is type 1 error, and then the second one is type 2 error. Let's begin with the first. A type 1 error is committed when a null hypothesis is true, but then is rejected. So when you reject a null hypothesis when it is true, then that act is known as a type 1 error. So type 1 error is rejecting a true null hypothesis. And then we have the second type of error, which is the type 2 error. The type 2 error is failing to reject a null hypothesis when it is false. So when the null hypothesis is false, and then you refuse to reject that hypothesis, then you have committed a type 2 error. So for a type 1 error to be committed, the null hypothesis will have to be rejected when it is true. Then we say a type 1 error has been committed. So rejecting a true null hypothesis means you are committing a type 1 error. And then failing to reject a null hypothesis when it is false means you've committed a type 2 error. Now let's take an example that explains the type 1 and type 2 error more clearly. So we have our null hypothesis on KNUST campus in Unity Hall. Each resident of a room is assigned a key to the room. If this key is misplaced, the person who misplaces the key pays an amount of 50 cedis, and then a new one is given to the person. So let's take our now hypothesis to be payment, or pay 50 cedis when a key is misplaced. Then its opposite becomes no payment when a key is not misplaced. So over here, we have reject the null hypothesis, do not reject. We have the null hypothesis is true here, the null hypothesis is false here. So a type 1 error is committed when the null hypothesis is true and then we reject it. So in this case, when a key is misplaced and then the student is not allowed to pay the 50 cedis, then a type 1 error has been committed. So we are saying that our now hypothesis here is that you make a payment when a key is misplaced. So you make a payment when a key is misplaced. So once the key is misplaced and then we refuse to allow that student to make a payment, then a type 1 error has been committed. So the statement is true, the key is misplaced. But then we are rejecting it, we are not allowing the student to pay that amount. And we've committed a type 1 error. But then, when so that's a type 1 error. So you realize that when we reject the null hypothesis, when the null hypothesis is false, then it's a correct decision. We reject the null hypothesis when it is false. So the key over here is not misplaced. So we are saying the student is not paying any amount. Then we've made a correct decision because the null hypothesis is false. So we are rejecting the null hypothesis, which means the key is not misplaced. The student has not misplaced the key. So the student is not going to pay any amount. So that's a correct decision. And then let's look at the second one. So if the null hypothesis is true, and then we fail to reject, null hypothesis is true, and then we fail to reject the null hypothesis, it's a correct decision. So realize the null hypothesis is true here, and then we fail to reject, it's a correct decision. So if the person misplaces the key, and then we fail to reject, that is, we don't say, oh, you've misplaced the key, but you won't pay anything. We fail to reject, as in we are accepting it, you've misplaced the key, so we are going to make payment, then it's a correct decision. But then, if the null hypothesis is false, and then you fail to reject the null hypothesis, and you've committed a type 2 error. So in this case, if any of the residents of a room misplaces his or her key, does not misplace his or her key, and this person is made to pay that sum of 50 cedis, then the type 2 error has been committed. Because you realize that the null hypothesis is false, which means the key was not misplaced. But then, instead of accepting that the key was not misplaced, we decided to not accept, that is, this is false, the null hypothesis is false. And then you are not rejecting the null hypothesis. As it is false, you are supposed to reject it. But you are not rejecting it. You are saying, oh, this student has not misplaced the key, but this student must pay. Then you are committing a type 2 error. So you realize that the type 2 error is serious than the type 1 error. Because if you misplace your key under normal circumstances, you are supposed to pay the 50 cedis. But then we decide not to make you pay by committing a type 1 error. So that one, you know you are supposed to pay and you didn't pay. So it's not serious. But if you take the type 2, you have not misplaced the key, but you are made to pay the fine or the amount. So that one is serious because you are not supposed to pay, but for whatever reason, a payment is now being demanded from you. So that's a type 2 error. So a type 2 error is serious than a type 1 error. Now let's look at level of significance. The level of significance is the maximum probability of committing a type 1 error. And the level of significance is denoted as A, or denoted by A, or alpha. So alpha is probability of type 1 error. And then the probability of committing a type 2 error is denoted by B, or the beta. So prob of type 2. So the probability of committing a type 1 error is known as level of significance and is denoted by the alpha, which is the A. And then we have beta, the probability of committing a type 2 error. So what this means is that, for example, if you're in any question, if your value of A is 0.05, which in this case is the same as 5%, what it means is that there is a 5% chance that you are going to reject a null hypothesis when it is true. That's what it means, because the A is the probability of committing a type 1 error, the maximum probability of committing a type 1 error. So if your A level is 0.05, what it means is that there is a 5% chance that you are likely to commit a type 1 error, or you are likely to reject the null hypothesis when it is true. In hypothesis testing, then we have the nature of the hypothetical tests are in two forms. We have one-tailed test and then we have two-tailed tests. For a one-tailed test can either be a left or a right-tailed test. So a one-tailed test is a test that is geared towards one direction. So it can either be a left-tailed test or a right-tailed test. So under one-tailed test, we have left-tailed and we have right-tailed. So if you take the left-tailed, so one, we have left-tailed. The left-tailed is the less than sign is used to denote the left-tailed test. So if you are stating the null and alternative hypothesis, after you've stated your alternative hypothesis, if you realize that the operation used in the alternative hypothesis is the less than, then that test is a left-tailed test. So first thing to note, the alternative hypothesis is used to determine the nature of the test, whether it is one-tailed or two-tailed. So as we are dealing with one-tailed, the alternative hypothesis is used to determine whether the test is a left-tailed or a right-tailed. So we have this for left-tailed, and then our right-tailed we have the greater than. If something is greater than, then it means it's more than or it's moving to the right. So as a result, that is our right-tailed test. So if you write your alternative hypothesis and realize that the operation that was used is a greater than, then that test is a one-tailed. Then we have the two-tailed test. And with the two-tailed test, the not equal to operation is used. So for any hypothetical question, if any of this is used in stating the alternative hypothesis, then it's a one-tailed test. But a specific one that is used will help you determine whether it is left-tailed or right-tailed. But when this is used in a question, then it means it's a two-tailed test. Two-tailed simply means it is both left and right. That's what it means for a two-tailed test. In hypothesis testing, there are three methods that are used to test hypothesis. We have the p-value method, we have the critical value method, and then we have the confidence interval method. So these are the three main methods that are used to test hypotheses. And then for any hypothetical question, if you are going to test a hypothesis, the first thing you need to do is to, one, state your null and then alternative hypothesis. Then the second thing you need to do is to determine your level of significance, which will always be provided to you in a question. Then the third thing to do is to compute the test statistic. As we move further, we will explain how a test statistic is computed. And the fourth thing to do is to state your decision rule. So the decision rule is either you are rejecting or you are accepting. Then the last thing or the fifth thing to do is your decision. So you first determine your null and alternative hypothesis. After determining your null and alternative hypothesis, try to identify whether it is a one-tailed test or a two-tailed. If it's a one-tailed, is it left or right? Then you identify your level of significance. You compute your test statistic, formulate your decision rule, and then finally you make your decision. So let's begin by looking at the methods. We take the p-value method first. With the p-value method, we begin with large samples. For the large sample, the p-value over here is simply the value of any z-score that is looked up on the z-table. So let's say if you have a z of 0, if your z is 0, if you look for 0 on the table, so 0 here is the same as 0.00. So if you take the table and then you check the horizontal side and then the vertical side, 0.00 gives us 0.5000. So that value, 0.5000, is our p-value. So this is p-value. So the p-value is simply the area of any z-value that we get. That is for large samples. So the area of any z-value is your p-value or your probability value. So in that case, let's say if your p-value is, if your z is 1.5, so z equals 1.5, then you take your 1.5 here and then 0, 1.5 on the vertical side and then 0 on the horizontal side. So that is 1.50, and that gives us 0.9332. So 0.9332. So this is our p-value for z equals 1.50. So the p-value is simply the area or the value of any z-score that you get when looked up on the z-table. That's our p-value. And there is a decision rule for the p-value. So for any hypothetical question, if your p-value is less than or equal to A, we reject the null hypothesis. And if your p-value is greater than A, we fail to reject the null hypothesis. So that's the decision rule. So when you get your question, and you go through all the procedures to find your p-value, and then you realize that your p-value is less than or equal to A, then you reject the null hypothesis. But if your p-value is not less than or equal to A, and your p-value is greater than A, then we fail to reject the null hypothesis. So when you go through these two procedures, when you take these two decision rules, then you now come and make your final decision. So for any hypothesis question, when your claim is a null hypothesis and then you are rejecting, the decision rule becomes there is enough evidence to reject the claim. So whenever your claim is a null hypothesis and then your decision rule is to reject, then the decision instead becomes there is enough evidence to reject the claim. And when your claim is a null hypothesis and your decision rule is failed to reject the null hypothesis, then your decision then becomes there is not enough evidence to reject the claim. Now, when we come to the alternative hypothesis, when your claim is an alternative hypothesis and then you are rejecting, if your decision rule is to reject, then your final decision is there is enough evidence to support the claim. And then when your claim is alternative hypothesis and your decision rule is failed to reject, then your decision becomes there is not enough evidence to support the claim. So you realize that almost the statements are the same, but the null hypothesis uses reject, whether the decision rule is to reject or fail to reject. And then the alternative hypothesis uses support. So those are the two key elements in stating your final decision, whether your decision is either to reject or fail to reject, when the claim is either a null hypothesis or alternative hypothesis. Now let's take an example on the p-value. So I'm reading the question. You think that the average franchise investment information okay, let's take this instead. In an advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. A random selection of 36 delivery times has a sample mean of 28.5 minutes and a standard deviation of 3.5 minutes. Is there enough evidence to support the claim at A equals 0.01? So in an advertisement, so let's look at the variables provided in the question. We have our sample size of 36, sample mean of 28.5, standard deviation of 3.5. And our population mean of 30. So first of all, let's state our null and alternative hypothesis. The question says in an advertisement, a pizza shop claims that its mean delivery time is less than 30. Its mean delivery time is less than 30. So we have our null hypothesis and then the alternative hypothesis. So the mean delivery time is less than 30. So this makes the alternative hypothesis the claim. And then our now hypothesis will be that the mean delivery time is greater than or equal to 30. So from this is a one-tailed test, and specifically a left-tailed test. Now we have our z to be our x bar minus mu over standard deviation all over the root of n. So we have our z to be x bar minus mu over standard deviation all over the root of n. And this is our test statistic. This is known as the test statistic. So from our variables we have 28.5 minus 30 all over 3.5 over root 36. And that gives us negative 2.57. So our z is negative 2.57. So now that we have our z, we'll now try to find our p-value and then state our decision rule. So we come to the z table and then we take negative 2.5 on the vertical side, which is found here, and then 0.07 on the horizontal side. So negative 2.5 here, 0.07 there, and that gives us 0.0051. So we have 0.0051. So our p is 0.0051. And then our a is 0.01. And then earlier, our decision rule was that if the p is less than or equal to a, we reject. But then if the p is greater than a, we fail to reject. So from this one, we realize that our p is less than the value of a. So we have p to be less than or equal to a. Our decision rule is therefore reject the null hypothesis. So that is our decision rule. And then our final decision is that there is enough evidence to support the claim. So we had a question, and then in the question we were given our sample size, sample mean, standard deviation, our alpha, which is level of significance, and then our population mean. From there we stated our now and alternative hypothesis, and then we identified our claim to be the alternative hypothesis. And then from there we were able to state that it's a one-tailed test, specifically a left-tailed test. And then we computed our test statistic value. That gave us negative 2.57. From there we went on to find our p-value, and then we had 0.0051. And then we stated our decision rule, which is p less than or equal to a. So the decision rule from that was to reject the null hypothesis. And then the final decision was that there is not enough evidence to support the claim. This brings us to the end of our discussion for p-value and a large sample. Thank you for participating.